Hi there. Welcome to another episode of eCHO Livestream. My name is Paul Ara, and today we'll be talking about like our Cilium networks policy, specifically focused on how you can secure Kafka clusters using Cilium. Um, so just to like bring us up to speed with everything that's been happening in the community, I'm just gonna just sort of like have a check of what has been happening with eCHO, and we can talk about that. So uh, let's start off with let's just look at what's been happening at eCHO lately. So if you're from the blogs, we have like a couple of like interesting technical blogs. One is learning about KubeVirt, a couple of like also eBPF related blogs. You can also see there's also, I'm just going to zoom this a bit. Oh, there is there is also this is related to like eBPF specific attacks. There's a couple of all the other interesting blogs, and if you want to like catch up with this, you can always like subscribe to like the eCHO newsletter from our bio, and you would get this. So we also have an interesting new case study. We have an interesting new case study from our CNAT, basically talking about like how they use Tetragon and how Tetragon has basically helped them like build security into like their systems. There's also an interesting blog on why Tetragon should be the standard in every Kubernetes cluster, right? Basically, this blog makes the argument that since Kubernetes by default doesn't come with like a runtime security layer, Tetragon should be that layer. So you should have like Tetragon in every, just like you would deploy like your Kubernetes cluster with like a CNI or other base components, you need to have like a fully functional Kubernetes cluster. So this particular blog post makes the argument that yeah, you should have Tetragon also as part of your Kubernetes deployment. So you should check that out. It's an interesting blog. So where there's also like the infamous Liz Rice book on our eBPF is now available as in audio formats. So if you're someone who prefers to like listen to like things via audio, just like me, then this is like this is one that's one resource you should definitely check out. There's a couple of other related there's a couple of other related interesting blogs. There's one on like uh, working with eBPF with Go. There's also a couple of ones related to AKS, and there's a eBPF from eBPF Book Club. I think this is a walkthrough of like the eBPS eBPF what is eBPF book, right? Uh, yeah, there's a video on that. There's also from last week. There's also like a video, a live stream from like the CNCF from the CNCF that basically talks about like how to use Cilium to enforce gRPC-aware security policies. So if that's something you're curious about, you should check that out. There is also some events that happen, some of them that's gonna happen soon, some upcoming events. If that's something you're interested in, you can check that out. So if you're just to let you know, like if you're curious about where I'm getting all of this info from, if you go to the Cilium website, a small reminder that if you go to the Cilium website, you can just go to you can sign up for eCHO. You can sign up for eCHO. I believe pretty much somewhere. You can sign up for eCHO on the Cilium website, and then you get like this delivered to your mailbox. You can also subscribe via LinkedIn, I believe, and then you'd also get like this. You get like this this eCHO newsletter. So eCHO newsletter is like a very good way for you to like keep up with what's happening in the community. And yeah, all right. So down to the business of the day. So today I'm gonna be talking about using Cilium to enforce gRPC-aware security policies. All right. So I'm sorry to enforce Kafka-aware security policies. So we just want to just maybe we'll just cover our bases by starting off with what exactly Kafka is. So if this is like the first time you're hearing about Kafka, so Kafka is a very popular message broker. And then what's a message broker? So basically, maybe we might do a little bit of system design 101 here. So basically, a message broker basically uses like something. So let's paint this scenario. Say you have you've got your I we built like an online store where we like sell stuff online, and then we have this as a microservice. We have like multiple services in this microservice and this microservice that talk to each other. So but initially when we started all of this, so take for example, when a user makes an order, right? A user makes an order, we create the order, we store it in a database. Maybe we have a function that calls that calls another separate. When I use the term service here, I'm not using the term as like a separate service. Maybe you have like the way you would do like your when you like segment your code like properly, like you have like a separate servers, maybe you have it like in another function or something, right? You call this external function, right? But everything happens secure synchronously, right? So if we walk through like the steps, the user makes an order, you create the order, we store it in the database. Maybe we call like the function that sends like a notification, like an email to like the user. Maybe we call another function that maybe like updates like the inventory and all of that, right? So, but then as you scale out, like this becomes like obviously like cumbersome to work with, right? There's so many things that could go wrong. For example, you have like single point of failure. So if you have all of this happening synchronously, for example, when a user places for order, there are a couple of things that need to happen, right? You need like a SMS, maybe like a email to be sent out to like the user. You need to like maybe sync up with the payment provider or something. You need to maybe like update like the event inventory and all of that. All those things that need to happen when a user makes an order, right? If you do all of this like synchronously, or you have like individual like services like talking to each other directly when something like this happens, this introduces like so many problems. Like you have a single point of failure. For example, if one specific service is down, maybe like say during like peak times, right? If one of the services is down, then you break that entire flow, and that becomes like it doesn't scale, right? That's the reason like message brokers exist. So message brokers use like a sort of like a pub sub model, right? So like Kafka is not the only message broker. There's like popular ones I've worked with, like Rabbit MQ. They all sort of like follow like the same like very base like principle. So in this case, for example, we're talking about orders, right? When an order is created, you actually have like you have like an event. You actually emit an event. You emit an event, and then you have like this event like captured by the message broker, and then you have like other services that are interested in using this event and can simply subscribe and actually take this event. So in the case where you have like multiple things need to happen, or multiple services need to like know when an order has been created, right? They can all just simply just subscribe and watch out for like what subscribe to. So I'm not speaking in terms of Kafka. I'm speaking in terms like message brokers in general, right? They can subscribe and basically see like basically see and consume this event, right? So it's a pub sub model. Specifically in the case of Kafka, you have something called like a topic, right? You have a producer, that basically you have a producer that basically publishes, and then you have like consumers that basically subscribe to like a topic and then consume from like the topic, right? So that's basically a quick crash one on like Kafka and like why message brokers exist. And for so many reasons, for example, if a service is down, for example, they you have like all these events all saved like with the message broker, and they can just come back and do it. Or if this peak time, for example, and there's so many events coming in at like the service can handle at a time, the service you can simply just throttle it, and the service you have all of that saved in the you have all of that, you have all of that thing being managed in the with the message broker, and you don't have to deal with like the complexity of all of that. So that's basically where Kafka, that's basically crash course on what like Kafka is and how what message brokers and what Kafka is. So we're going to be talking about specifically today how you can use Cilium to like secure your Kafka deployment. All right, so crash course again, Cilium. If you've not heard of it, if this is the first time you hearing about Cilium, you're probably, this is probably not your first time. But yeah, Cilium is basically like Cilium provides networking, observability, and security for your cloud native environment. And one of the very interesting things you can do with Cilium is write network policies. And these network policies, you can use them basically to enforce how traffic moves between your cluster, right? So you can do layer 7 policies with Cilium. You can do like HTTP based policies. You can do, we talked about like, if you saw like, if you at the beginning of the live stream, we had one talking about like gRPC aware policies. So you could do like layer 3 policies where you can, the standard like Kubernetes network policy where you can control traffic like based on like the IP addresses, like the ports, right? Or you can also do like at a higher level, at the protocol level, like HTTP, you can enforce like HTTP policies, right? You can write like network policies based on like paths, based on like routes and all of that. All right, so we're gonna be talking this particular one, this particular echo is gonna be focused on like Kafka clusters. All right, so we actually have, if you look at the document, if you want to follow along, you can actually go to like the Cilium documentation. Just search for Kafka and you'd see a part of the Cilium documentation that talks about like securing Kafka clusters, that talks about securing Kafka, talks about securing Kafka clusters. All right, so I'm just gonna zoom this a bit just to be sure like it's clearly visible from the other end. All right, so I'm just gonna do this. I have the environment prepared. So let's just walk through like what exactly we're gonna be doing in our demo, right? So we basically have a Kafka cluster that basically we have a Kafka cluster that we have a bunch of like producers, we have a bunch of like other services consuming from that. And so this example here is kind of like uses like an old, basically, so Kafka has this thing called Zookeeper, and Zookeeper manages all like the distributed parts of like Kafka, allowing Kafka all the parts, everything related to be running Kafka in a distributed way, right? So all the partitions and all of that, right? In Zookeeper, these days you can run Kafka without Zookeeper. You can run Kafka with something called Keraft, but like I think that's like out of like the scope for this. We're more focused on like the Cilium part. All right, so in this case, we've got like two topics. So as a reminder, a topic is basically where like you actually when you broadcast like a message, so right, or when you create an event, you have this event like saved in a topic, and like so what like you can publish to the topic, or you can produce to a topic, and you can also subscribe from a topic, right? So you can consume from a topic. All right. So in an example here, we've got two topics. right? We've got the first topic called Empire Announce. So there's a lot of like Star Wars reference in the documentation, and if you're like me and you're not really like familiar with Star Wars, this could put you off a bit, but hold on, this is actually a very interesting demo. All right, so we've got two topics here. There's one called Empire Announce, right? We're just gonna ignore like what is used for. We've got, so the crux of it is we've got two topics. We've got Empire Announce, we've got Death Star plans, right? All right. So what does our image looks like? What does our deployment basically looks like? I'm just gonna show you the actual deployment. I think it's, so if you look at the Cilium repo itself, you can go to examples in the Cilium repo and you see somewhere that says Kubernetes Kafka. All right. So let's just look at what our deployment looks like, right? So we've got like a Kafka broker. So this is this is the deployment that has like Kafka running as a single pod. This is a couple of our thing. This is basically like how Kafka talks to like Zookeeper and all of that. So the important thing to note from this deployment is, so if you actually look at this EMVs here, where it says that says name Kafka create topics, we actually have like two topics here, right? Empire Announce and Death Star plan, right? So we've got these two topics here, right? All right, so that's like that. And then we have another deployment that has Zookeeper in it. And then we have a service that exposes Zookeeper. We have another service that exposes Kafka. And then now we have a deployment. We've got this deployment. We've got one deployment called Empire HQ, right? We've got another deployment called Empire Outpost 888, right? And we've got another deployment called Empire Outpost 999, and then we've got another deployment called Empire Backup. All right. So this is just like we're gonna keep this like very small and really, really straightforward. So the crux of all of this is that Empire HQ, like this pod Empire HQ, or the deployment representing Empire headquarters, it's the only pod that should produce messages to Empire Announce or Death Star plans, right? So we're basically saying that this pod is the only pod that's allowed. This Empire HQ pod is the only pod that's allowed basically to like publish message or produce messages to these two topics here, right? And then Empire Backup is a secure, which is allowed. This Empire Backup is the only pod or the only deployment which is allowed to like subscribe or consume consume from the second topic here. And then this is the random outpost that needs to consume this Empire Outpost 888 can consume messages from Empire Announce topic, and this one can also consume messages from our Empire Announce topics. All right. So let's just basically this is a better like this visualization like will really like sort of like help this make sense. So we have our Kafka cluster here, right? We have outpost 888 and outpost 999, and these two outposts here should be able to. We've got those two outposts here. We've got Empire HQ. We've got like Empire Backup, right? So this sort of like tells you like this should be able to consume. These two outposts here should be able to consume from this topic here. Then this one outpost should be able to consume from this desktop plans, and then this other outpost here should be able to produce to like the both topics we actually have. All right. So let's just go and we're gonna take this and actually create the deployment for this. All right. So I have let's just look at what my Kubernetes cluster setup sort of currently looks like. I'm gonna just close. Gonna do this. Okay. I'm going to just delete the the kind. So I just had like I had a cluster I used to test this out like prior to this. So I'm just gonna delete that so we actually restart on a clean slate. I'm also gonna terminate this. Just gonna close up all this other extra tabs. All right. All right. So uh, let's fire up our client cluster and go through like the whole process of like installing Cilium. So it's pretty straightforward. If you have like so in my case, I'm gonna be using kind. So I'm gonna say kind create cluster. I believe I'm just gonna grab for this. I should have this. Okay, kind create cluster. I believe it's config, and then I have a I have a this called config, which yeah, I did. I'm gonna be sure I have that. Okay. Yeah, this is kind config. All right. So it's gonna go through the whole process of like setting up kind. All right. So I'm just gonna. So if we actually look at the kind, if we look at the, it's a single node cluster. It's a pretty much it's a single node cluster. I think this should have like if I'm not mistaken, I should have disabled like the CNI, the default CNI that comes with kind, but I believe this should still work. All right. So I have the Cilium CLI installed already in this uh in this cluster. So I'm gonna do I'm just gonna do I believe Cilium install. Cilium install. So this will basically install our Cilium. We can do Cilium status wait just to see that if Cilium has been properly installed. And just to be sure everything works well, I can just look at the nodes on this cluster. I can look at the nodes on the cluster. I'm just going to expand this. I can look at the nodes. I don't have the alias set up. I'm just going to get NO. All right, our node is ready, and it's taking a while for like Cilium to get up, but that will get up in a bit. All right, so let's just go back to let's go back and then let's go back and basically install yep, put up install like this create like the deployment and the services and everything for like for the manifest we just actually just looked at now. All right, so I'm just gonna all right, so Cilium is working fine now, so we can just simply we can install this. All right, so we should do get the pods, the services. I believe the pods, the services. Yeah. I keep forgetting I don't have alias set up here. All right, we're just gonna give this a while, and this would set up like for like the containers to like be done setting up. All right. So for us to like easily work with this, we're going to like in like defense in like we're just gonna open this like in a very easy order that's gonna make this easy for us to work with. All right. So and if you want to follow along, like I'm basically just taking this straight out of the docs, so you can always like you can always follow along. So I'm just gonna see if the pods are up. All right, pretty much all the pods are on except Zookeeper. All right, so in each of the windows, I'm gonna have like this. I'm just gonna open like a couple of tabs to make my just working with this like quite easy. So this first tab, I'm gonna open a shell like in each of the pods, right? So for each of, if you actually look at the commandants, so this is for like the Empire HQ terminal, right? Gonna, oops, that's not what I meant to do. Copy first line. All right. So now we have a running shell and the Empire HQ. We have a running shell for the Empire HQ. We're gonna do same thing to same thing too for Empire backup, right? We're gonna do same thing too for Outpost 888. Oh, yeah, I got to SSH into like the remote PC I'm using. We do same thing for output SSH. So this is just prepping like making our lives easier. We're gonna do the same thing for Outpost 999. So basically, this we just have like a bunch of like requirements, which ports and subscribe, which ones can consume from which topic, which ports can subscribe to which specific topic, and the kind of like the end goal here is to be able to demonstrate that we can write network policies that can be able to ensure like a port that has like a specific role. For example, we can assign like a port or a group of ports like a specific role. Like for example, this port is a consumer, and as a consumer, this pod should be able to be able to consume from this specific topic, right? As a producer, this pod is a producer, and this pod should be able to only consume from this specific topic, right? Like we don't want like a, so think of this from like a security perspective, right? We wouldn't want like a scenario where like say random unauthorized services can consume or like broadcast to like certain topics. So think if we go back to like the other example we're using, if you have like if a random like pod, if some random person can just wake up and like produce a report, means you can essentially like just create like fake orders that don't exist, right? And that's from a security point of view, that's really bad. All right, so we have like all of that, all of this. We have all of the terminals pretty much set up. So for each of the pods in our environment, we have opened like a cell session where we can actually run a couple of commands in there. All right, so let's start with the consumer client listening to their respective topics, right? So so this is, we've got like Empire backup, right? We want to just get a minute and clear this. So we want to Empire backup, the Empire backup, if you remember from like from the from the manifest file, if you were following along, you can just pull this up, Empire backup, right? Empire backup, right? This pod, this pod here. We actually want this pod to start listening to the desktop topic, right? To the desktop plans topic. All right. So now this pod is listening to, we've got this pod listening to this topic now. All right. So we're going to do, we also want outpost 888 to start listening. Remember, we've got like two topics. We've got like the desktop plan topic and we've got the Empire announcement topic. So we also want this pod, here to start listening to the Empire announced topic. So we want outpost 999. We have one outpost 888 to start listening to the Empire announced topic. All right. So remember, this is basically a pop sub model. So you have like this consumers, right, subscribe to like the topic, and whenever we have like an event push to like the topic, this consumers like can consume from it, like the name implies. All right. So we also want like we want to outpost 999, which is the next one, to also consume from the Empire announced topic. So if you go back to, if this feels like a bit convoluted, you can actually go back and look at like the diagram we have here. So we want outpost 888 and outpost 999, these two outposts, to be able to like consume from the Empire announced topic here. Right, we want the Empire backup to be able to consume from the Death Star plans topic, and then we want the Empire HQ to be able to like produce, to be like the only one that's able to like produce to the Empire announce and Death Star plans topic. All right. So let's just test that everything is working like correctly. So we're gonna try like so we're gonna try listening to in the. So let's see that everything is working correctly. In the Empire backup, we've got this Empire backup, right? All right. So now we're gonna broadcast the message from Empire HQ to like we're gonna broadcast the message basically that says happy 40th birthday to General Taj. We're gonna broadcast this message, right? We produce this message to the specific topic. So if you actually look at the command, it says we're basically echoing April announce this, and when we're piping this into like this bash scripts that we have here, and that basically, and the topic, the arguments, we're given like the specific topic, right? All right, so we've broadcasted this message, right, to Empire announce. So if we remember which specific pods are subscribed to Empire announce topic, right? Outpost 888 is subscribed to Empire announce topic, or is consuming from Empire announced topic, and you can see like the message we broadcasted from the Empire HQ down here. And if you also look at like outpost 999, you can actually see like the message we just broadcasted here, right? So like in your ideal, like in real world, like if you think of like a real world deployment, right? This is the same way we will basically like pass say if there was an order, we would pass like the details of the order and the payload, and then have like this different services subscribe to this topic, consume from like this consume and like check out like the information from the payload and do whatever they need to do with it. All right, so we've got this, you see like this message. So because our Empire backup is not subscribed to, if we look at, let's go back to our terminal, we'll call this because our Empire backup is not subscribed to, or is not consuming from like the desktop plans, right? So here, so if you see me keep using like publish subscribe confusingly, it's just because using like pop sub instead of like produce consume is because like pop sub is more like generic and like, but it's basically still the same thing. And I hope like you don't get that, you don't get that mixed up. But yeah, so the reason we don't have this message, don't have the messages like in other pods here, in this case is because we don't have the Empire backup is subscribed to the dead plans topic, right? And not the Empire announced topic. So we wouldn't get the message we just broadcasted here on the Empire backup, on the Empire backup pod. All right, so now if we want to send, like, let's say we want to send a secret message to like the dead plans topic, right? And remember, our Empire backup is the only client that subscribes, is the only consumer from the desktop plans topic, because it's supposed to, the dead plans topic is supposed to be like basically like a secret topic, right? Not accessible to like every other person, right? So from the Empire HQ, we're gonna send them. We're basically gonna. This is for Empire announce. We want a message going to desktop plans, right? So we're gonna do this, right? And now if we look at Empire backup, we see like, since this message, we produce this message to like the desktop plans topic. So it's only Empire backup that can actually see this message. If you look at other parts, they don't see this message, right? All right. So all right. So everything is working as expected, right? So what is wrong? What is wrong with our setup right now? So the very first thing, like, is we have a case where basically any of the pods can basically subscribe to like any topic, can basically consume from, and I keep using subscribe, can basically consume from any topic, and that becomes like a problem, right? Which isn't that's not something we would want to happen, right? All right, so how do we now we're gonna see something, why this is something that's pretty wrong here. So we're gonna go to outpost 999. We're just gonna kill like this. Outpost 999 is supposed to be like a consumer, right? Right, but from here we're actually gonna broadcast a message to like the Empire announce like announce topic. And if we do this, if you actually look at this, it says Vada Bood at Empire Karaoke topic. So now we're basically outpost 999 that was supposed to be like a consumer. Suddenly we can produce a message from outpost 999. And from a security perspective, that's really bad, right? We don't want like just random clients to be able to like produce to like a topic, right? So yeah, so basically any outpost container can access like any topic on our Kafka broker, and that's really that's really a bad sign, right? So how do we secure our Kafka cluster in this case? This is where Cilium sort of like comes into place, right? This is where Cilium network policy comes into place. So the Cilium Kafka policy allows you basically write the same with the same very declarative model we're used to for writing like every other kind of Cilium network policies. You can basically write network policies that basically control like how traffic flows in and out to like your Kafka clusters, right? So now in this example, right, we basically want to limit to be we want to basically we only want an outpost to be able to consume from an Empire announced topic, right? We don't want like we don't want an outpost to be able to like produce to the topic, right? That would be we don't want an outpost to be able to produce to this topic or consume from this other desktop plans topic that we consider secret, right? And yeah, so if you actually look at this diagram, we've got like two outposts here with the label, and we've got this. If you look at the manifest files, we have them labeled with. Just gonna zoom this a bit so you can actually see this clearly. So we've got two outposts here. We want this outpost to be able to consume from. We want this outpost to be able to consume from the Empire announced topic, but we don't want the outpost to be able to consume from the Death Star plans topic because that's secret. It's only the Empire backup that should be able to consume from that plan. We also don't want any of the outposts to be able to produce to the Empire announce topic, just like we've seen just like we just demonstrated now. So to do this, how do we do this? We do this using Cilium network policy. Let's just go and look at what the actual network policy looks like, right? So we've got like we're basically the same familiar Cilium network policy we're used to. We've got like a network policy. We have like the API version, the kind, the metadata, just like any other Kubernetes CRD. And then we have like this is like pretty much if you've written a Cilium network policy, before, this is pretty much like the standard stuff. You have like if it's ingress or egress from like the endpoints, matching labels and all of that. We have like the port where like Kafka is on and all of that. All right, so the very important part of this network policy I actually want us to look at is this place that says roles, right? So we've got this we've got this rules that says here Kafka, right? Where we're defining like, hey, this the high level protocol we're using here is Kafka, and then the role is, if you remember, role is a producer, right? Produce to the dead plan. So we want like this Empire HQ. Remember, we have our Empire HQ pods, and we want our Empire HQ pods to be able to produce to the dead plans topic, and to the dead plans topic and to the Empire announced topic, right? Another we can Empire outposts, and then we have, and then this is pretty much this, and then we have like we want the outpost, right? We want the outpost as consumers, and we want the outpost to be only able to consume from the Empire announced topic, right? And then in the third part of this network policy, so we want the Empire backup port to be able to consume from the dead plans topic, right? This is the only permissions that we want to be allowed. So we can just go and apply this policy in our Kubernetes cluster. So I'm just going to go to like the main, going to apply this policy to a Kubernetes cluster. And we have, so if we do care get kubectl get CNP, right? We have this called secure Empire Kafka, right? So to do kubectl describe this. kubectl describe CNP. I spelled skip CTO wrongly. Right. So basically, this is the three-pointed part of this network policy. So just to reiterate, we want Empire HQ to be able to produce to the dead star plans topic and Empire announced topic. We want the outpost to be able to consume only from the Empire announced topic, and then we want the backup to be able to consume from the dead plans topic. So let's see if our network policy actually works. So when we actually try to now, if we go to like the Empire announcement, if we go to the outpost 999, one of this outpost, and then we try to produce to the Empire announce topic, we get an error. And basically, if you look at this error, so I'm just gonna make my entire screen. So if you look at this error, basically this error this doesn't destroy a random error. It actually tells us that this is an unauthorization. So it's basically, let's look at the logs, it says not authorized to access topic Empire announce. So we actually see our Cilium network policies actually works and actually prevents like the outpost from accessing a topic they are not allowed to access. And if we try also consuming from a topic like the Death Star plans topic, we're not allowed to consume from the Death Star plan topic, because the only from the example we made, like the only pod allowed to like consume from the Death Star plans topic is the Empire backup, right? So if we actually try consuming from this, you actually see like authorization field. All right, so I'm just gonna kill this. Yep, that's we see that this is blocked. All right, so I hope you actually found that interesting. I did particularly find this interesting, that you can have like your Cilium, you can have like a Kafka cluster, and then write like network policies that are very specific to Kafka. That's specific to Kafka, specific to like concepts like like producers, consumers. They are not generic concept, like they exist specifically for Kafka, right? So the fact that you can write like network policies specifically for Kafka, taking into all like the concepts and constructs that exist in Kafka is quite interesting for me. So yeah, thanks for coming to this episode of eCHO. And if you wanna, this is all in the docs. I literally lifted this straight from the docs. And if you wanna try this out, you can definitely try this out. Yeah. So eCHO happens every Friday, and be sure to like stop by next week Friday. We've got lots of something. I'm pretty sure something more exciting next week Friday. Thanks for coming in. See you around.